All right, here, what do you think we're going to do with this one? Negative infinity to positive infinity. So if you look at the graph of that, it's kind of a strange looking graph when you don't even really have to know what it looks like, but it's something like this. It comes down and then it goes up and then it wiggles around and everything. So we really don't care because it is continuous throughout. There's no value for x that causes an asymptote. But the complication here is we go from negative infinity to positive infinity. So this is like a double dipper, right? So let's go ahead and set it up, and I think you can easily get the inside part. What I'm going to do is I'm going to pick a value in the middle. So I usually pick 0 if that's up for grabs. So let me pick 0. So I'm coming down here from negative infinity, I'm going to positive infinity. Probably that's all I have to say to you, and you know what to do. Am I right? So the first integral is going to be from negative infinity, so I'm going to call that b, or you can use t or whatever, and I'm going to take it to 0. So the limit as this side approaches negative infinity of b, and then we have this. This is not integration by parts. You see this is a u du, so this is not as hard to integrate as it might look like. This is our u and that's our du. I'm not going to go through that, but it's not a bad problem. So see if you can figure out what the next integral is. I'll say t approaches something. I'll let you finish it. It seems like once you do one or two of these, they all kind of work the same. Johnny, what do you think the second integral might look like?
It'll be the limit as t approaches infinity.
From?
From 0 to infinity, or 0 to t.
Right. And then the same function right there. So, and then, as I said, this looks like a bad integral. That is not. All right. We're not going to go through that. Well, I'll just tell you that at the end of the story it diverges. All that for diverging. So it approaches infinity or negative infinity somewhere in there. I forget which. I think it was positive infinity. If that's a double dipper, I should have mentioned this one in case it shows up. What do you think about this one? What complications does it show? I'm going to call this a double dipper as well. When I say double dipper, we had to put a limit for this end and this end. Why do I call this a double dipper? Because this is not negative infinity. It starts at a precise point, and then it goes here where I have to take a limit. Why is this one, why do I have to use two limits again on this one?
It's integration by part, or not by parts.
This one?
The other one
Up
partial
here?
fractions.
No, this one's,
The one down there.
oh, this one? I'll tell you what that is. That's actually very easy, and it took me a while staring at it. But just setting it up is what I want right now, and then I'll tell you how to actually integrate it. We're not going to do it, but I'll tell you how. Why do I call this a double dipper? What's the other complication? Do you see something else, Morgan? I see this as a complication. So I have to make a limit here. But what else is wrong, so to speak? What else is the problem with that one?
You have to do with the denominator.
Yes, what can't be there?
0.
Right, I can't have a 0 there because that would cause that whole thing to zero out. Now also -1, but we're only interested from 0 to infinity. So therefore I've got to do two limits. So Morgan, the first limit, as you said, would be starting. This problem can't start at 0 because it's an asymptote there. So we're going to say as b approaches 0 from the right, and that will go from b to, and then where should I end there, Morgan? Do you have an idea for me? I can't go to infinity right now and put another limit there. So you have an idea, what can I put here?
Another variable.
Yeah, not a variable, but like what I did here. I split it up between, I picked a value in between here and here, and I picked 0 just for fun.
Oh, so you pick a value between those two?
Yeah, so what do you wanna pick this time?
One.
Yes, that's what I did.
Oh.
Great minds think alike.
I was gonna say one earlier, but I felt like weird.
No.
It didn't feel right.
Alright,
Great minds feel weird.
alright. So now we've gotten this integral from almost 0 to 1, so we have a little bit more to go. So Gianni, what would be the other limit?
As t approaches infinity.
Right, just a little bit left over. From t approaches infinity from what to what? Gianni?
1 to t.
1 to t, right. And then we have the same integral there. This is a very sneaky integral. I stared at it and finally looked it up. And this is, if this is u squared, if u is square root of x, does that show you what it is? If you, that means that's u squared, a is 1, and that might get it for you. So we have here u squared plus 1 squared, and outside of here a u. Does that make sense? What's du if u is square root of x? This is derivatives, so 1/2 runs down in front, 1/2 x to the negative 1/2, and that means 1 over x, 2 square root of x. So actually, if we set this up, all this is a du, except we have to deal with a -2. So we put in a -2 here and a negative 1/2 outside to know if it's down the denominator, I need a -2 out here. So what is this? If we have x squared, if we have a value for u squared plus 1 and a du, you recognize what that would be?
What, one of these? This pink?
Not pink,
Oh,
not pink. Do you recognize it?
ln maybe.
No?
Is it tan?
I think it's tan. Yeah, tan, an arctan.
I'm on the ball today.
Yeah, you are. So I'm not going to do that one,
Yes,
but
you are.
that is an arctan in disguise. So, all right, that's kind of all the situations that are improper that I can think of. I have a little theorem to go over with you tomorrow that helps us decide whether they converge or diverge quickly in certain situations where we don't have to do it out. So that'll be helpful, but you don't get to that till tomorrow. So I'll go ahead and give you the assignment, and how many, are we timing this side of it?
Yeah, but I accidentally did it late, but I think it should be like 8.
Okay, that's fine. Then we'll keep this, I'll put up the assignment and we'll be done with part 2, and that's all I have for you, Brendan. All right, so let's do, on 8.8, I like the ones with the pictures at first so you can get an idea of what's going on. So let's do 9, 10, 11, and 12. They have pictures. And then we'll do 2 of them without the pictures. And we'll do 46 and 48. So let me write this down. So this is our second attempt on 8.8, so I'll call it 8.8B. So we'll do 9 through 12. Then we'll grab 46 and 48. Now I didn't necessarily teach you this with pictures. I did show you on some of them what it looked like. And our blast from the past will be 8.6, number 33. All right, Brendan, make it your goal to be with us tomorrow. Till then, bye-bye.